This is my fifth year on matrix based for the concept honors and G is student. I'm RANJANA Dutta from the Department of Mathematics, the Graduate School College for Women. Here, some problem we do today. Let xd be a matrix space and let d star xy is equal to minimum of 1 and dxy. D is a matrix and we have to prove that d star is also follows the rules of a matrix space. Now, since the postulate 1, since D is a matrix, therefore dxy is greater than 0, which implies that d star xy is greater than or equal to 0. Number 2, if d star xy is equal to 0, then dxy is equal to 0. Then according to applying the metric property, this implies that x is equal to y. So d star xy equal to 0 implies that x is equal to y. Now let d star xy is equal to d star xy is equal to 1. Then dxy is greater than or equal to 1, and so dyx is also greater than or equal to 1. So d star yx is equal to 1 and written as d star xy. Again, if d star xy is equal to dxy, then dxy is also less than or equal to 1. Thus, it implies that dyx is less than 1. Hence, d square yx is equal to dyx implies that dxy is equal to d square xy. Hence, the third condition is also satisfied. Now, for the fourth, d square xz is less than or equal to d square xy plus d star xy plus d star yz. By the definition, d star xz is less than equal to 1. This implies that either d star xy is equal to 1 or d star yz is equal to 1 for the values of the above inequality. So d star xy is not equal to 1 if, and then dxyz is not equal to 1, then d star xy is equal to dxy and d star yz is equal to dyz. So d star xy plus d star yz is equal to dxy plus dyz, which is greater than equal to d of xz. So d of xz is greater than minimum of 1 comma d of xz is equal to d star xz. Hence, d star xy is equal to d star yz is greater than or equal to d star xz. Hence, d star is a metric for R. Now, the another problem. See, let f be a set of all real valued function, continuous function defined on 0, 1, close interval 0, 1, if D is defined by dfg is equal to supremum of fx minus gx, x belongs to close interval 0, 1, and D is a metric for f. We can check that M1, M2, M3 and M5 are satisfied. So we will only show the fourth postulate. FGH belongs to F. Fx minus hx can be written as fx minus gx plus gx minus fx, which can be written as shown on your screen. So dfh is less than or equal to dfg plus dgh. Now take another example. Prove that if xd is a metric space and x and y and z are points of x, then d of xy minus d of yz is less than or equal to d of xz. By the axiom 4, we can write it as d of xy as d of xz plus d of zy, and which is less than or equal to d of xz plus d of yz, which on transforming we write it as d of xy minus d of yz is less than or equal to d of xz. Also, d of yz can be written as less than or equal to d of ix plus d of xz, which gives us d of yz minus d of xy is less than equal to d of xz. Combining these two, we can say that d of xy minus d of yz, the modulus, is less than or equal to d of xy. Now, norm of an element of a metric space. In each metric space is defined on a notion of length. The size of the element x is the real number denoted by norm of x, which is the distance dx0 and is known as the norm of the element x. It satisfied the following properties. Norm of x is greater than or equal to 0. Norm of x is equal to 0 implies that x is equal to 0. Norm of kx is equal to modulus of k into norm of x, and norm of x plus y is less than or equal to norm of x plus norm of y. Now, metric induced by the norm for a given set X is a metric D can be defined as D of xy is equal to norm of x minus y. Such a matrix is called a metric introduced by the norm. Let f and g be the two real bounded functions defined on the closed interval 0 and 1. Then the norm of f and g can be defined as norm of f is equal to 0 to 1 modulus of fx dx. Similarly for g, for every x belongs to the interval 0 and 1. Thus, d of fx can be written as norm of f minus g, can be written as 0 to infinity integral over modulus of fx minus gx into dx, which after further calculation gives us d of gf. So also d of fh is equal less than or equal to d of fg plus d of gh. Hence, today this much only. Thank you.